Hello, I'm Vivien. I'm a artist, biodesigner. Before, it's fun. Before I was student there in 2017, but not here in Montparnasse. So it was another place. So I was student in Master R, so innovation approach of education, or something like that in English. And I built many Fab Lab and biodesigner community in Paris. And after I move on other things. So I talk now about other things. So we talk about biodesign practice, but for me there are a tiny bit problem. What about we talking? So we talking after about just I present where I work. I work now in engineer school, Institute for Technology, with De Vinci Institute. So it's an engineer school with a business school and with infographics school, but we try to work with engineer school side. So we have a master, the name is creative technologist, and so we work on most of time on I would say that interactive computer-human interaction, but with different sort of approach. One approach is more from artificial life, like artificial intelligence, electronics, swarm robotic, 4D or whatever you want. The other side is human learning, like pedagogy, learning, cognition, like use VR for cognition, for disabilities or things like that. And some other people work on resilient future, where it's more about biomaterial, biotechnology, and how we can use for make new type of interface too. So me, I work in resilient future, and we go talk about what is biodesign. But biodesign is not one thing; it's many things. So it's a tiny bit a problem. But I think we have to just start to the start. So this is a long story about a different point of view on what is biodesign or could be biodesign, because biodesign is not a good word, it's very problematic word. And normally it come from the genetic science, but not from design, so it's tiny bit different. And you have different science who use exactly the same words for talking about really different things, so it's really a huge problem actually. Because if you talk about biodesign, yeah, maybe someone think about bio-inspiration, like Leonard de Vinci, or people like Janine Benyus, who talk about innovation inspired by nature, like biomimicry. Even if the word biomimicry is really problematic in French or in American or in Dutch too, because it's really another word, it don't mean exactly same things. And most of time when we talk about biomimicry, in fact, it just copy a system and make the same system with the artificial system. So in pure engineering. So it's really another mind. But actually we go more on designing with life, and this is really an old story. In fact, this story starts by the start of humanity, like domestication and human selection, and exactly where we live now, because we live in full artificial world where we have adapted every species who have survived until now. So we have to deal with it, and it's interesting to think about that. And yeah, we have selected many species for heat, because heat is a technology. It's another way to see the technology, but it's a technology. And we have developed many materials during the dawn of time, like collagen, casein, albumin, algae, or all these other things. And after we have moved to modern chemistry, and this modern chemistry have changed really, really a lot of things about how we think about material and what is a material. And the question have a tiny bit move at the up when we have started to think about the biology, because biology is just the child of physics. And so here you can see three important works for me, like the Ernst Haeckel, who is most of time used by artists also for like inspiration, but it's a really important work in taxonomy of species. And the work of Form and Growth, Darcy Thompson, who is really interesting because he tried to find a sort of relation between physics and the form of life, and why every species have specific forms, even if they have some relation between them. And another really important work for me, and you understand maybe at the end, it's a work of Alan Turing on the chemical foundation of morphogenesis, because he explained many relations and how the things are separate or distribute in the space, even like pattern, natural pattern. So, of course, science and the development of science, like the discover of a DNA or the development of bioengineering, are really deeply modify our perception of what is life, what is material, and what is possible to do. So actually, we are in really moment where it could be really interesting to think about how we can use these tools for maybe another purpose. And as actually, maybe, I don't know if you know, but most of our production is produced by biomanufacturing or biotechnology, if you prefer, where we can use it for produce grafts or medicine or molecules, food, beverage, many things from really different molecules, or like animal cells, plants, microbes, yeasts, etc., etc. And even we can produce artificial things too by synthetic biology. And actually, this is really an important step in the conception of what is life. Because this changes the perception of life as a machine or something who can be designed. And actually, the word biodesign comes from this domain, not from design. So it's, I think, a huge importance. So we tiny bit move now. We have a sort of background on different biodesigning practice, but there are, of course, more than that. I have chosen more designer who have a practical approach, not so much designer who have a so abstract approach, because this exists too. So I start by Alexandra Daisy Ginsberg. I don't know if you know, but it's really interesting works. She produced these works on the Synthetica kingdom. So she speculates, it's speculative design. She speculates about, okay, now we have the capacity to create a new kingdom. So what happens if we take this seriously? If we build a really synthetic kingdom, maybe we can grow things. We can directly grow vegetables who are already an artifact. So how we can do that? How can we program life for produce directly objects? And some other designer I've already tried to make it. Like, this is again speculative, but yeah, you have your papi, your grandfather in the garden who tried to grow his tools in the giant bioreactor. So it's a funny day on the beautiful sun. And yeah, maybe you can produce ceramics without eating anything, because you use biocalcification from many bacteria who can do it. So that means you don't need eating resources, so no consumption. You can produce biocalcification also like this for make structures, or like the last works of Neri Oxman lab, these perfect shoes who can disappear from bacteria who produce some of type of plastic is certainly PHE, but okay, long discussion. But yeah, even the packaging is made with PHE, like a cocoon, I don't know, packets. And where we start to go, because after I present my works, here you can see some works where people start to think, okay, can we program matter for have some interaction with this matter? Is possible to produce something with like a computer from living life? And so this is the old works I have done before on kombucha, because yeah, I work a lot on kombucha from long time now. All works too, so more biodesign things. And yeah, we start to go on what I think it's interesting actually, but from my effectively practice, I mean, I mix a sort of speculative design with microbiology or zygomology, if you prefer, is the older name of fermenting science, and material science and system engineering, because I try to build machines with life. So I do a thesis, of course, on biodesigning the growth of living biothing by monitoring. So it's really at the intersection of design, biology, and bioprocess. I mean, bioengineering, and I try to think about what is actually this new question about materialities and energy, and how this question of like ecological crisis push us to rethink about our relationship with materialities, because this is a huge question after everything I present before. So me, I work most of things on artificialization of life, because for me it's done. We live in artificial world, we have to deal with it. But of course we have to be ethical. And I think that's like a sort of general organology and bioaffordance. I don't know if you know organology, but general organologies come from like Deleuze or people like this, Guattari. And it's more like from philosophy, but it's think about technology as a sort of medium. Like we have produced tools, in fact, for have the capacity to have a relation with the world, because most of organisms don't need that. They have organs for do that, but we don't have this capacity. But our capacity is to build machines for do that for us. And bioaffordance, it's just a sort of another point of view on the affordance. I don't know if you know it, but in design is a really basic concept about, I don't know, if you have I don't remember the name, but for open a door, you have the things for open the door. Everybody know as human open a door, even when it's child. It's something like just basic, we know that. But the thing is, we call about affordance. And the thing is, bioaffordance is a sort of opposite point of view. It's can we build affordance for living things like non-human? Can we build machines or even other ecosystem where other organisms have the capacity to have an affordance for themselves, and of course for us too, because we are functionalists and utilitarists, because we need to survive. So I have, after, just for go more faster, I have tried to just think about how I can understand all the practice who use bacterial cellulose, for example, in design. Because me, I try to just understand who use bacterial cellulose, like kombucha, you know, for make things. So I have tried to see if there are many people who use it. And of course, every domain uses it in a really different way. But the problem is nobody have tried to push it together, because for me, it's a problem. Everybody produce a new knowledge on these things, but nobody talk together. So it's like everybody live in tiny bubbles. So I take all these projects and I try to make them together on a map. And I have tried to be really functionalist, because I work with engineer. And yeah, I try to think about, okay, if we think about practice, like make things, we can consider, you start by experimental activities. After you have unique, arts, crafts, artisanal, microproduct, industrial. So that means we talk about scaling up production, okay? And the other side, we have usage. So that means non-prescribed is like feel something. After contemplative, after critique, material design, object design, research design, prêt-à-porter, because it's more of industrial already. Applicative design is really industrial. So this more and more applied. And so you have your map, and after you put the project in, and you check, okay, what is the relation between these projects? And if can we see something or not? But the most interesting part is this part, because I'm in the junction between research and art and design. So this area is really interesting for me because it's speculative, and he used machinery and sort of poetic machinery for make absurd objects, I mean. And so for continue on my side where I go, exactly, it's, okay, now you have seen there are many projects, many things. We think, okay, we can maybe grow things. So can we do it for real? Okay, I have tried to do it. So we have grow like different objects with electronics directly insert in the living system. I mean, we use bacterial cellulose as a system for encapsulated directly the component, because it can be used like a process. It's like, if you want, but maybe it's too long, you can put electronic on the trees and wait for the trees eat the electronics. And after you have a connected trees maybe, but it's maybe too long. So you can use just bacteria. It can be maybe tiny bit faster. So we have grown these things. Just I hope there are no the song, because it's really boring music. Up. So this is a tiny bit video, because yeah, it's more easier to understand when you see. It's the difference between research and design. So yeah, you have things, and most of people make artifact or blah 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 or drink it. So yeah, can we insert electronics in? So we have produced this moving shoulder. This is like a PCB with kombucha, if you prefer. I think it works 10 minutes. And this gamepad will survive a long time. Yeah. So, so for me, the question of my type of biodesign, because as you already see before, there are many types of biodesign which is possible. But yeah, for me, the most interesting side is to shape the matter, try to see if we can really, like a sculptor, think about how we can directly grow directionally the matter, if it's possible. So I try to find and understand what is a biofilm, has a what that mean for make design who are adapted to biofilm, not think what we want about biofilm, but what is a biofilm for make a form who is adapted to his own grown. And so I start to try to grow different things. So here it's a part of the gamepad who grow. And yeah, I grow shoe, and I start by grow sort of tiny pockets, because if you can grow pockets, you can grow a bag, you can grow shoes, you can grow whatever, because after it's just a more complex form. And yeah, again, this shows. And so now we have, okay, a sort of process from science with a sort of design mindset where we try to push the knowledge from science for build something with it in a sort of shape, and think about this shape and the shape who are adapted for this living form who are not us. I mean, really radical other mind. You don't think like you, and you can never understand it. But it's really cool to work with. And yeah, can we make something with a sort of same idea, but using machinery again, algorithm and sensor and all the things for build the habitat of these. So I have tried to go more deep on that. So here you see the basic idea of a really emerging domain with engineering living material. We try to push together the idea of to use bioreactor with a sort of metamaterial and other things, and maybe design algorithm for make optimization. And so you can use waste and all these things together for produce and grow whatever you want. And on this side, I go more on the thermodynamic side first, because I was sort of interested about the question of entropy versus negentropy. I don't know if you are really familiar with that. But normally, entropy is exactly the opposite of negentropy, and we produce many entropy by our technical system, because that means we dissipated energy, and the fact is life tried to make exactly the opposite. It tried to organize energy and build things with this dissipation, but after a moment it died too. So I have used many algorithms for produce topological optimized form and try to produce form directly from living mats, if you prefer. And I have built systems like a thermodynamic system for try to think about how these dependencies can work together. And at the end, I have tried to build this sort of machines who are just a bioreactor who live with the machines, and the machine helps the living form to produce more matter. Because I don't understand why we don't use actually really all the dissipation for do not produce more things. And so now I try to go tiny bit more far with the question of if we can produce these machines, it's possible or not to create machines who are not just like we already talking about extraction and control, but maybe tiny bit more something where the negotiation is necessary. So I have started to think about maybe build machines who are half-alive and mix like biohybrid machines, and this machine can grow things. And I start to make it. Actually, I built it these weeks, but I can show you for a moment the image. Maybe you see it more later. But the idea is to see if we have access to this sort of new machine, can we go out of the classical mindset of use technology for dominate the nature, or these don't change anything? I don't know. It just the point is for me is why it's interesting to work with living thing, and it's why biodesign is interesting in sort of point is we have the capacity to produce machinery and sensor who give us the capacity to understand really non-human organism, and I feel this is really a huge opportunity for build systems where can we make more sustainable and maybe symbiotic things. But of course, we have to to find a way to do not use them as we use actually, because it's really toxic for a moment. And we have like the gamepad to think about how we can build something who can be destroyed, because we build things for just have something who stay here for the end of time. So this is end.
Thank you. Your favorite meme? That's great. I don't know what that says about you as a person, but so do we have any questions from the floor first? I think it was pretty dense. You spoke about a lot of stuff. No? Oh.
Thank you for the presentation. I just joined in the later half, but it's super nice to 3D models, and maybe they're real as well. I just have this question that how do you think this biotech or soft robotics, they can be used or misused in the current digital platforms like Meta? Maybe people can misleading, do some greenwashing thing, or as you mentioned, it can do something bad to the planet as well. So how can we regulate it? It seems super nice, but how can we work with the emerging legal framework as well to regulate the digital platforms and environmental laws as well?
Really huge question. For me, it's like we have to. I think there are different stages. I mean, we have to think about a part of where we live as a system. I mean, we have to think this system as something we have inner things, and outer things. So how we can plug it or unplug it from another system and maybe make it more sustainable. Actually, it's already the mindset from, I don't know, cradle to cradle for the most older, but after many other designers have already talking about that. Or in Fab Cities, they have tried to build a sort of same mindset from Fab Lab movement. I think it's a good point, but it's really complicated to build it. But of course, we have to make politics for that. We have to think about a city as a sort of huge organism who have to just digest some things and out on others, because actually we don't think this sort of circularity. We don't think matter like something will appear or something would disappear. We just think about produce something. This thing is like indestructible. Okay, of course it's cool. But if it's indestructible, it's just pollution. So.
Yeah, exactly. Thank you. Yeah, Balwam from Fab Cities. Yeah.
Thanks.
Oh, okay. Thank you for sharing. It's really interesting seeing your work. The controller reminded me a lot of Existence and Cronenberg, and I wondered what your relationship to science fiction is, or if you're a science fiction fan, or what inspires you outside of design.
In fact, it's why I'm talking about speculative design, but I try to be in tension between realistic things. I mean, it's real, it's work for real, but it's not a product. It's more speculative design, in the sense of I feel people don't really ready about take care about things. I mean, really have the conscious about we can build a sustainable world if we want, but of course we have maybe to live with these living forms, really with huge proximity, and yeah, we don't want to live in this world, most of people, because of course we move out of this pathogenic world in sort of point, because yeah, the world can be pathogenic. You know, the limit in symbiosis. The pathogen or the synthesis is really the the symbiosis. Symbiosis is tiny bit really similar. I mean, many organisms live with another, and sometimes they help them during like years, but after a moment it starts to be maybe toxic. Depend of the the milieu. Depend where you live, because the resources are not enough. So the thing change, and we have moved as humans far off these forests and things who don't live with them, because they are really in sort of point dangerous. But we have to find a new deal with that. Like, we have to accept maybe a sort of, I don't know, corruption, or I don't know, something like, to deal with these living forms. Because if we continue to live in this like giant biolab artificial world where we live, we of course continue to risk to have many viruses who destroy us or things like that, because it's not stable. It's just because only one toxic things can just take the lead on the environment. So. But yeah, complication.
Last question.
Hi, thanks for the talk. So I was just wondering, like, how does the Turing pattern influence your work, and how does the philosophy of Deleuze, and maybe do you have a stance on negentropy as a whole?
Wow. Okay, let's go. No, I think maybe you have to read Stigler. There are some reply on it, but not all Stigler. Maybe read after Simondon. It's maybe a tiny bit better. And maybe Canguilhem, because you are in science life here. It can be something cool. Georges Canguilhem, really good French philosopher. But yeah, complicated. But the thing is, in fact, there are philosophers, of course, most of them, but it's how they see our relation with technology. because most of them are related to philosophy of techniques or technology, but not from history, more from French side philosophy. So it's really another side. And they try to understand how this is sort of system of mindset and how we change our perception of reality, because it's why exactly why artifacts are done. It's for modify our milieu, our relation with the milieu. So if you create a hammer, all the world start to be a nail. So it's a basic idea, but it's a sort of things like that. So if you
what about Turing patterns?
Because my thesis, it's morphogenesis of the matter. So morphogenesis comes from the Alan Turing paper. So, but the really interesting point is Turing creates this algorithm, in fact, maths, just for understand the chemical separation of molecules in the liquid. But in fact, these solve many problems about the repartition of cells in the space. So it's really fun because, you know, also Turing is a guy who produces sort of really interesting side on computers. So actually there are really huge, more relations than we expected between maths, computer, and life forms as mathematics, like biomathematics. And I'm interested on that because if you want to produce system like surface where bacteria can grow on, in fact, you need to optimize the surface. And what is the best optimization is possible? Is the classical repartition of the cells in the space. So if you prepare the surface with algorithm, you risk to have better results. So
yes. What about Michael Levin?
We talk after.
Yeah.
Okay, thanks so much, Vivien.